Hello, welcome. Let's provide answer to this question. GCSE text for grade 10 UK student. Here are the first four terms of a quadratic sequence, which are 2, 3, 6, 11. We are to find an expression in terms of n for the nth term of this sequence. In our tutorials, we deal with quadratic sequence, the steps involved in finding the nth term of a quadratic sequence. Let's bring to bear that concept. So we have our sequence with our 2, 3, 6, and 11. We need to find the common difference between the successive terms. So between 2 and 3, the common difference is going to be 1. So we have 1 as a common difference. Then between 3 and 6, the common difference is going to be 3. When I mean common difference, this minus this, the number at the right minus the one at the left. So this minus this, then 11 minus 6 will also give us a common difference of 5. Okay, so you can see that the difference are not common. So this is not the common difference you're looking for. So let's find the successive difference here. 3 minus 1, I believe that will give us 2. Then we find the difference between 5 minus 3 will also give us 2. So the second difference, this is the first difference, this is the second difference, and the second difference is common. So we can say that the common difference is always equals to 2a equals to the second common difference, or the second difference, which is the common difference. So this simply means that our a, which is the first term, will be 2 divided by 2 equals 1. Then the nth term is given by an squared bn plus c, where the a, b, and c are constant to be derived. Then the n is the n we are looking for. Now, in order to do this, we are saying that where n is just 1, 2, 3, 4, continue. That's the number of terms. So this 1, n equals 1, meaning the first term. And this first term is also the a that we have as what? 1. So we can say that when n is equals to 1, from here, your t1 will be equals to a n squared, which is 1 squared, which will still give us a. Then plus 1 times b plus c. This will be equals to the first term we had here as what? 2. Here, the first term here is 2. So we already know what the a stands for, so we are going to equate from here and say that a equals to 1 implies that 1 plus b plus c equals to 2. I believe you can see that the 2 unknown is here. 1 is a constant, can be transferred there, meaning b plus c equals to 2 minus 1, and that will be 1. That gives us the first equation. 2 variables unknown, so we can have that. Then let's also see that when n moves to 2, when n is 2, then the second term, which is also going to be this, will be 3 equals to a, which is 1, right? A is 1, n, which is 2, meaning n squared. When you square n, you get 4. 4 times 1 will still be 4, plus b times n. That will be 2b, then c will come. I can see a constant here. When transfer here, become 3 minus 4. That will be negative 1. Meaning this will be 2b plus c equals to negative. Is it negative 1? Yeah, negative 1. That becomes the second equation. So we are solving equation 1 and 2 simultaneously. When you are solving simultaneous equation and you have the coefficient or the variable you want to eliminate being the same, and they have a different sign, you perform a subtraction. So that simply means that we are going to subtract one equation from the other. Anyone can do. So let's say we have equation 2 minus equation 1, equation 2, meaning the corresponding term 2b minus b. That will give us only b. C minus c will be 0. So minus 1 will be equals to minus 2, meaning the value of b is minus 2. When put into any of the equation, either 1 or 2, we can get that of c. So we can see that from equation 1, let's take it from here, we can see b will be negative 2 plus c equals to 1. C is the only unknown. So what do? We send the minus 2 to the other side to become positive, or we add 2 to both sides of the equation, meaning c will be equals to 1 plus 2, c will be equals to 3. So here the a is known as 1, b as negative 2, and c as what? Positive 3. So in this case, we can see that our term, the m term, is going to be Tn equals to a. What is our a? 1. 1 times n squared will still be n squared. B is minus 2. So minus 2 times n, minus 2n, plus c, and our c is what? 3. So this becomes the nth term of this sequence. Meaning if I'm looking for this 1, 2, 3, 4. If I'm looking for the 5th term, I only put n equals to 5. 5 squared, 25, minus 5 times 2, 10. 25 minus 10 will be 15. 15 plus 3 will give us 18. Meaning the next term will be 18. We can generate a lot of terms following the nth term. I guess you follow the concept. This is how we deal with quadratic sequence. Thanks for watching. Like, share, and comment. Bye-bye.